So welcome everyone. I'm Carlos, and it's my great pleasure to be with you today. We are going to have an excellent talk about using LLMs in AWS. So we have very simple rules for the call today. We are already recording the call, so we will upload the recording to the YouTube channel, and we will also share it later on in the meetup group. As you can see, microphones are disabled, but you can still make questions using the Q&A on the top right. And I will try to address them in context if it is possible, so that the question doesn't get lost. So I will interrupt Lekan if possible, or we manage it at the end. At the moment, we have over 60 participants registered. I think it will still go up with the time. And what is the Gen AI Gurus? Well, we just inaugurated this group in June, just less than 2 months ago. And the only goal is to exchange and learn from other generative AI gurus. This is an open community for newcomers and also experts. And we plan to do a series of expert talks to help us learn in a guided way from basics to advanced, including hands-on concepts. We have a series of expert talks already prepared in the pipeline, as you can see. Already, the one in August 31st is announced in the meetup group, but we have 2 more in September with experts in different domains to dissect audio ML paper, and also to learn about how to distribute LLM execution with Hive-Mind and Petals. And we have also prepared a talk in end of September benchmarking self-supervised learning methods with a Google developer expert in machine learning. We will have also a community call probably on the 15th of August, but we need to clarify that. If you follow us in Meetup, you will see that. And this is the community leads of the Gen AI Gurus. This is speaking Carlos Hernandez Vaquero. I'm a software development manager at Bosch, and I lead the data-centric software group, which is a part of a bigger initiative aligned with the digitalization of the Bosch group. Selina, you want to present yourself?
My name is Selina Singer. I'm working for KPMG currently. I just joined our global advisory team for risk management at our tech initiative Gen AI. It was like 1.5 weeks ago, so I'm a newcomer in this topic, but I'm very happy to learn about it day by day and to support Carlos and Gerd in the community organization.
Thank you so much. And Gerd?
Yeah, thanks, Carlos. This is Gerd. I'm CTO of CloudAce, one of the biggest public cloud providers or partners of Google Cloud. I'm super happy that I could provide expertise and passion here for AI in this group, and don't want to consume more time here. Let's kick it off.
All right. So we get nearer to what we care about. So Olalekan, or Lekan, as we like to call him, is an expert in this domain, and is, as you can see, we have the great luck to have him with us today. So he's an AWS hero in machine learning, and he has extensive experience in developing and managing both data platforms and machine learning systems. He also contributes to several open source projects. And with this, Lekan, I pass it to you.
All right, thank you, everybody. Thank you, Carlos. Thank you, Gerd, and thank you, Selina. Thank you for the brief introduction. We'll get right into it, but also this is an expert set. We're all experts, and I'm still also very learning. I'm still learning this field. Like I tell my team members, I try to read 1 paper a week. That can be very difficult, but I would just share with you what I've learned so far, and then please feel free to ask questions. If I cannot answer them, I'll be super happy to also learn from you all, and then also refer, just see how we learn together. Let's get right into it. So I share my screen just quickly. All right. Okay, good. Now I believe you should be able to see my screen.
Right, we can see.
All right, so it's 0 to 1 with LLMs on AWS. This is not a deep dive into any of the research papers, not a deep dive into how to fine tune LLMs, but it's just going from 0 to 1 and what it means to go from 0 to 1, right? So from the table of contents, number one, I'm super excited to be here, largely because this is my second slide deck that I will be preparing this year. So I don't like preparing slides. If I'm preparing slides, that means the occasion is very, very important. So I'm super happy to be here. This is the second slide that I'm preparing this year. All right, so we'll just look at the genesis of LLMs, the basic, just a brief touch briefly on the research paper that talks about attention is all you need, that came out of Google and another university. And then we'll look at how to get from whatever it is to zero. We'll look at a couple of use cases. Definitely a lot of us have been seeing 1 or 2 use cases or even more use cases in the industry, but I will touch on a couple of use cases that maybe have, and also on those use cases, just address a bit of the ethical concerns that people might have with regards to using LLMs or using generative artificial intelligence. And then we'll go from how to get from 0 to 1. This is just getting from wherever we are right now into 0, and then we'll go from 0 to 1 on AWS. And I'll just show you a quick demo using LangChain, which is one of these frameworks of Python libraries that we can use to build applications on LLMs. Like Carlos rightly said, if you have any questions, please feel free to ask the question, and then I think Carlos can interrupt as we're going so that we don't get lost in the questions. All right, so the real genesis started from the Transformers paper, the research paper published by Google in 2017. Even though LLM just started gaining a lot of traction, maybe towards the end of last year or towards, I think, about late 2022 or early 2020, late 2021, when OpenAI released GPT-2 or GPT-3. But then the paper, the build up to that started way back in 2017 when the guys from Google published this idea about having not going beyond recurring neural networks and really making sure that ensuring that we can have attention with regards to how we deal with text tasks when it comes to machine learning or artificial intelligence. And the architecture is very, very simple, right? We're not going to go into the details of the architecture. It's just matrices, vectors, more calculations in there, and being able to retain context of what the text that is being predicted. You know, in the past, right, when we had recurring neural networks, we could just predict maybe the lazy dog went somewhere, right? But with attention, it's able to pay attention to context, which is a lot of words before the word that you're trying to predict from, and then also use that word to really go forward in time and look at what is really relevant to what you're talking about, because it's trained on large amount of data sets and really continue generating more and more text. That's where the idea came from. And if you really want, I think we'll make these slides available after. You can check out the slides at ArchiveX or something. And you can also go through the paper to readily build your understanding of where this is actually coming from. And what it does basically at the very high level, again, is enable models to scale the understanding of relationships between words. That's why you would see when you ask ChatGPT, what do you understand by this? It's been able to use that relationship between words to predict or to really generate text. The same applies to, quite similar approach applies to vision models, right? We're using image generation, right? It's been able to understand the relationship between text and the image and then use that to predict or generate new images. And more importantly is the fact that it can efficiently use parallel computing across multiple computers to really scale training and prediction. And this you will see, we will not go into fine tuning in this discussion, but you will see that when people are talking about frameworks like deep speed or PERT, it's really leveraging as much compute as possible to fine tune or train these LLMs. Yeah. And then what does that look like, right? The next word prediction, like I said before we could just say the lazy dog or the lazy Lekan is sitting on the car or something like that. Right now, if I were to say, what country is Latvia, right? We can see models being able to come up with text, even though sometimes some of them don't really make sense if they're not fine-tuned on context. But sometimes, a lot of times, they are getting really smarter, especially with ChatGPT and a couple of other models like that can actually go and really understand what you're asking about and really come up with text that matches in a way or the other what you're talking about. And just to also call out here that there have been a lot of talk about hallucination. That is actually very real. When you ask a model a question, if you put in ChatGPT, who is Olalekan Elesin right now, it's probably going to tell you that he's a Nigerian because of my type of name, how my name is structured. I have a child somewhere that is grown up, is a 70-year-old, blah, blah, blah. That's what is called hallucination. And in using, just a pro tip, in using LLMs, when it comes to using it like this, be aware that these kinds of things might happen. And this is where you then want to fine tune on your own data set or use other techniques to really make sure that it works on your own context. Yeah. And what has really been fueling this innovation when it comes to LLMs is it's not just the fact that we can train with billions of parameters. It's largely driven by the fact that in the past, right, when we were building machine learning models, and even it still happens these days, it gets to a point where the performance of your machine learning model plateaus, even though you put in more data sets. On the other hand, with large language models or generative AI, is that the more data you give it, the better it performs subjectively. So it's not like people have different performance benchmarks, but subjectively, what we have seen over the years is that the more data you put into it, the better it performs. But putting more data doesn't mean it comes at a cost, right? It's I think I read some reports sometime that to train ChatGPT alone, it costs about $20 million or thereabout. Training these models are really expensive. That's why outputs of training these models are then what we call foundation models, which is starting from Roberta, BERT, GPT-2, GPT-3, and Bloom. And just to add a fun fact here, when Bloom was announced sometime early this year or late last year, I put in a text and I asked it a very, very interesting question. I think it was around when Black Lives Matter happened, right? I just asked it a random question just to make you understand that there are also risks with regards to using LLMs as they are. And it wrote something very, very discriminatory. There was bias in the data itself. This is one of the things that I believe Selena is dealing with or will be dealing with in the coming months, weeks, years, right? And these are things that we have to pay attention to when using LLMs. There is the hype about it, but there is also the reality that there is bias trained into this data, into these models because the world is already biased, right? Okay, going from what we already know right now, which is a brief introduction, into going to zero, which are the basics. And I talked earlier about foundation models. So Amazon SageMaker offers the SageMaker JumpStart, where you can see we have available foundation models, like the one that came out last week, which was the Llama 2 from Meta AI, popularly known as Facebook. Cohere, we have Hugging Face Hub, where a lot of people are already using right now. I hope if you're not using Hugging Face, please get on it, use it. It's really very easy to get started. We have Cohere and we have Anthropic and a lot of other things, a lot of other model providers or foundation model providers. And that's, for me, I just came up with the word. I'm not sure it exists, but if it does, hopefully I'm the first person to use it. It's LLMs as a service. These are services where you don't have to train your own large language model. It's already been trained, hooked up as a service that you can then use. And providers like Amazon Bedrock, which is still in preview, but then you can have access to it if you request. Things like OpenAI, ChatGPT, Amazon Whisper, GitHub Copilot, which are coding assistants. Hugging Face Hub is also an LLM as a service. Cohere and Anthropic, and a lot of other providers offer this LLMs as a service. And then for me personally, I love LLMs as a service because I don't want to train my own or fine-tune my own model. I just want to use it and solve my problems. And then finally, you have LLM app. If you're developing applications on large language models, you can definitely look at technologies like LangChain or Llama Index, which was formerly called GPT Index. And talking about SageMaker JumpStart, this is, if you have an Amazon AWS account, if you log into your AWS account, you go to SageMaker, create a SageMaker Studio, you launch a SageMaker JumpStart, you can easily see the available foundation models. And there are more than this actually, but this I just took a screenshot to give us a brief overview. Here you can see the Llama 2, 7 billion parameter, 70 billion. You can see Jurassic from, I think, A2AI, and you can see Cohere. Underneath that, you can also see their foundation models for images, right? So if you are working with images and you want to generate images, example, you're a content creator using images for whatever you're using it for, you can consider using this. However, these are really kind of expensive to host on your own, but in any case, this is what Amazon offers at this point in time. And then we go to the to LLM as a service for coding assistance. And here you can see that people believe that it makes them productive. I would say yes, because I've used it in our internal use case also. I think ChatGPT also allows you to generate code. But more importantly, more recently, is that it can also, Code Whisperer also work in your Jupyter environment, right? Which makes it, most of us as data people or data scientists or machine learning engineers or whatever we are doing, we usually work within a Jupyter Lab environment. So it's also possible to integrate LLM as a service, which is Code Whisperer, in your Jupyter environment. And then we go into what was announced yesterday, right? And a lot of us, we do data storytelling. And a lot of us do data storytelling, where I want to know how to improve business performance. And as much as we are data scientists, as much as we are data enthusiasts, we want to train the best model possible. The people where we work would always usually ask us for what is the story that we can tell with the data that we have today. And this is one of the capabilities that AWS is also bringing out, or also announced recently, which is still in preview, where you can simply ask a question to an existing data set and it generates this fancy story for you, right? But this is all I want to say about this. Okay, good. And then going to the Bedrock, which is the popular LLM as a service where AWS is really pushing right now. The foundation models, in this way, you don't have to train, you don't have to host your own models on your own. It's way cheaper than, I think it's about more than 90% cheaper than hosting your own on SageMaker. In any case, if you have to use SageMaker, maybe you want to fine tune your own model, you definitely might want to use SageMaker. But if you only want to use an LLM as a service, then Bedrock is your way to go. Hopefully it becomes, it becomes generally available. And that I think yesterday also they announced the agent, which is you can train or let's say build an LLM application. We could do it with I've forgotten this one, LangChain, but now Bedrock wants to offer this as a service where you can train an agent and give it a couple of prompts so that it can also make function calls, which is what people are used to when it comes to OpenAI, where if it gets a particular if it needs to perform an action which is external to generating text, it can make a function call to an external system. And these are cases, this is then bringing it home to use cases that we work with on a daily basis, even how we can innovate within the companies that we work, where there is a set of activities that you can use the large language models to generate text, and then after generating text, you make a function call to an external service and then continue the activity. So these are the advances that I think we can benefit from using large language models. And then we go from 0 to 1, real life examples. We all know the general candidates, text generation, writing articles, code generation, making me a better programmer, investment portfolio optimization. This is one of the things that I'm trying on my own, and I've seen people use it to actually ask maybe a few large language models to imitate an investment banker or an investor, and then generate based on a couple of metrics, come up with the best performing portfolio. And it tries to do that as much as possible. You can also, it's also applicable in drug research design, where when you see combination of drugs, the compounds that make up drugs as a sequence of text, then you can ask the LLM to regenerate or generate new sequence of text based on previously available sequence of text. And these are things that a lot of people are exploring to see how they can push the boundaries of large language models to really improve drug research and design. It doesn't mean that the drug goes into market, it has to still go through FDA approval and all that, but it can really hasten or quicken the rate at which we can, as an industry, do drug research. You can also use it in industrial design when you're building chips, and then if we can arrange the chip design as a sequence of text, then it is possible to also use LLMs to look at how can we optimize the sequence of text. I'm not sure. I think back in secondary school, I think way back in Nigeria, we did something about motherboard design for computers, right? And how circuits actually travel, or how electricity travels across circuits. And these are things that if we write out as gates, which is gate A, gate B, or things like that, we can ask LLMs to figure out what is the best route so that saves energy. And you can think of different applications of LLMs in different ways, as long as you can represent your data as a sequence of text. And then codifying human consciousness. This has ethical concerns, but in general, these are just Q&A bots. And I will show you an example of how you can how this can be done. But these are ethical concerns as well, because if you are able to codify my consciousness, then that means you don't need me anymore as an employee or something like that. But these are things that in general, organizations and companies that are building these LLMs and pushing this innovation are really paying attention to. And for, maybe the last on my list is the machine to human negotiations. This is maybe a way of saying, when you build an LLM agent, like you saw using Bedrock, or when you're using LangChain or Llama Index, you can already inform it about steps to take when negotiating, let's say, human contracts. And this is one of the examples I saw in when people are using it. So people are already using it in supply chain, where they allow maybe their suppliers to, instead of having to negotiate with hundreds of human contractors or human agents, they're codified and then put it into LangChain, where it interfaces with their suppliers and then negotiates based on the context and based on the environment. So you can think of the scale at which that works. And also the ethical impact. Does it mean that we fire people? Does it mean that we lay off people? But these are ethical concerns that organizations still have to deal with. And we, as builders of large language models and builders of applications on large language models, we have to pay attention to. And definitely there are tons and tons of more use cases. I would recommend that if you can, pick up the book, Age of Spiritual Machines. It's written by, I've forgotten the name of the writer. I cannot also find the book, but it's a really good book. It gives us an understanding of what might be possible, even though it's a science fiction, but it gives us an understanding of what might be possible with large language models and where humanity might take large language models to. That's more on the philosophical side. And an example of codifying human consciousness, right? So you can think of data sources. Let's say a lot of us when we're younger, we used to have diaries or notes where we put things that we write about ourselves or write about the experiences that we have. You can think of your social media posts as part of your documenting your consciousness or documenting the things that you think about. Your work documentation. If you're a software person, you probably have a GitHub account. That's where you store your code. You've written blog posts, you have posts on Twitter, you have text messages and all other messages. In that case, you can then convert all this information that appears to be text, translate them into word embedding, store them in some vector database. We'll get into an example shortly. And then people can interact with that chatbot. And we already see people doing this, right? There was news about some, what's this thing called? Some social media influencer that was able to work with some technology company to put all our posts as text into something, and then people were interacting with it. And you can think of, this is just a simple Q&A, but these are people codifying human consciousness and using large language models to scale their interactions with people. Right, so we go to a quick demo. Any questions so far?
There is one question I bring with me, Lekan. So far, you have shown capabilities of AWS, but actually, if you look at the mass media, they talk all the time about ChatGPT, OpenAI, and its cooperation with Microsoft. So how, in your perception, does AWS offerings compare to those of the other cloud providers? And if I would have a new project where I want to use LLMs, maybe is there some kind of guidance on which cloud should I use?
Okay, yeah, I'll answer that quickly. So to be honest, I have no preference for cloud, for the cloud provider. So don't be hinged on any cloud provider. Use what works for you with regards to the cheapest possible means that you can afford. So one of the use cases I wanted to show later in the discussion was a use case where Amazon AWS, it required me to host my model on the LLM that I wanted to use on Amazon SageMaker, and it was way too expensive. I would be paying 1,800 euros a month just to host that model. Turning to OpenAI, it only cost me 3 euros a month because I don't have to host any kind of infrastructure, right? So I would say build on what you can afford at this point in time. That's basically it. Don't be tied to any provider. The only reason why I share AWS is because I use AWS on a daily basis. But if I have to go to Google Cloud or Azure, because Azure has integration, Azure endpoint with Azure OpenAI, I would use it. For me, I don't have a preference.
Yeah, understood. And one more, you have shown a slide about Code Whisperer, yeah, which, if I got it right, is something like the OpenAI Codex or GitHub Copilot, right? It's a code generator. Is there public benchmarks that people can refer to decide which is the best one? I also think there is open source LLM models optimized for code generation. So is there any place which is well accepted to compare different LLMs with such benchmarks?
Yeah, there is actually. So I remember when Hugging launched their own, I've forgotten the name, Stable Coder. They launched it a couple of weeks or about a month or a month and a half ago. And they published the benchmark with regards to how it performs in comparison to other code generators. I cannot remember if it's code with maybe Codex or GitHub Copilot was better, but I remember that the Hugging Face, when they published their own version of the open source, which is open source, Stable Coder is actually open source, they also published a couple of benchmarks around it.
Perfect. Thank you so much.
All right, good. So I take you to my Jupyter environment on my SageMaker Studio. I'm going to show you how to run the Llama model. Just very quick example. I already set up the environment. I already deployed the model, as you can see, just to show you one more time, right? So SageMaker JumpStart, this is the starting point. You can see here it says foundation model, text generation, foundation models, image generation, vision models, text models, and a couple of them. And here it has over 83 foundation models. Let's see what they look like, right? And again, feel free to use any cloud provider. This is just because I use AWS on a consistent basis. Here we have Falcon, we have some from Hugging Face. We have lots and lots of foundation models that you can use out of the box, or also fine tune or refine or fine tune based on your own context. And for me, using Amazon, it's very, very, very easy to deploy. It's just 3 lines of code. And then it gives us how to invoke the endpoint. And I'm just going to show you a quick example, right? Which is what is the recipe for mayonnaise? And it's able to generate, this is standard things that we already do on a daily basis, right? And then I'm not going to run through it again. Another example, if I'm going to France, what am I expected to see? And it's able to also to respond in there. And a couple of more examples, but I want to show us an example of why when working with LLMs, there's something called prompt engineering, which a lot of us have become familiar with. And let's go back to the. So 0 to 1, also prompt engineering. When working with, how do we ask questions? And I've had a couple of colleagues of mine tell me, oh, I want to take a course in prompt engineering. I'm not saying you shouldn't take a course, but a lot of us are smart enough to know how to ask very, very intelligent questions, right? And I believe that anyone born today, even because I have a 3-year-old toddler, he asks me really, really intelligent questions. And if I ask him, what do you mean? Then he refines the question and then asks again. And this is all about prompt engineer, how to write prompts. If I were to ask you and ask anybody and say, give you the first version and say, please write me a blog post on generative AI on AWS. Length of paragraph, maybe 300, how long the text should be. You probably just write something very basic. But on the other hand, if you look at this the right side of the screen, and I say, you are a senior solutions architect with 10 years of experience, machine learning experience, having studied computer science for bachelor's and distributed computing for master's. You have worked with Amazon SageMaker since inception and built open source projects based on the paper. Attention is all you need. Write a technical blog post titled yada, 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 yada. if you look at this, these are two different things. And let me show you what the, can you still see my screen? Can you still see my screen? Can you hear me? Hello?
Yes, we can see, yes.
All right. So the first prompt that I showed earlier, write a blog post title, how to build this, and this is what it comes up with. Your useful assistant. Introduction, generative AI is this, what is SageMaker, benefits of generative AI. It doesn't go into any strong details. But then when I ask it with a second prompt, which is more detailed, explaining who the assistant is, what the assistant is meant to do, how the assistant should think. Then it goes, generative AI is a hot topic, benefits, easy integration, how to build, and it goes into the step-by-step of how to build. Even though it's not correct, that's what I said. Sometimes some of these things hallucinate because of the time, the cutoff time on which it is trained on the particular data set, right? But it's able to, with a better prompt, it's able to really think about, not necessarily think, but generate better text based on the questions that I've asked to it. All right, so let's get back to our slide. And then when you want to add context, there's tons of techniques like zero shot, few shot. I would not go into all that right now. They became popular, I think maybe they were popular about last year, middle of the year to the end of last year, but people have actually improved on top of that and then went back to another paper that was published in 2020 by Facebook Research, which is a retrieval augmented generation for knowledge intensive tasks. And what this simply means is that if you don't have to, what it actually, in general, what it means is that if you have to train your own or fine tune your own model at every point in time, that is a lot of money that you have to pay. But how can we augment the knowledge that exists within the large language model with some context that is available, that is stored somewhere, and then add that to what the LLM is, give that as an input to the LLM, and then the LLM refines that, or large language model refines that and makes it more understandable. And please feel free to read this paper. It's an awesome, awesome paper. And what it looks like is the architecture is very, very simple. Similar to what I showed you earlier, where there's tons of information that already exists from social media posts, from anything, from even blog posts written by you, your Confluence page at work, your SharePoint. You convert all that information into word embeddings, which is mathematical representation of words as vectors. Those vectors you then save in a vector database, and there are tons of vector databases out there. So there's the FAIS, which is from Facebook, which is open source, but then it's not as scalable as other ones like Quadrant, like Pine something, but there's tons of vector databases out there. What you then do is if you do a search to your vector database, and it tends to find text or vectors that appear to be close to what you're asking for. By returning the top K, which is more like a KNN search, right? By returning the top N or top K documents with the context, you now pass that information into your LLM, which it then refines and makes it have context. This is way cheaper than having to train your own large language model or even fine tune on your large language model. And I would say this approach gets you from 0 to 1 in hours, as opposed to days where you have to fine tune. And what this means is that you can easily prototype large language model applications as quickly as possible wherever you within your work today. One example I just touched on, I cannot share it because I've also already deleted it, is that we had a presentation at work, and I was able to hack together using this retrieval augmented generation approach. I was able to hack together a large language model that could answer questions based on the industry that my workplace is in let's say 3 hours, because I didn't have to fine tune a model. I just had to take from here, take LangChain, convert to vectors, save in a vector database, and then let people ask questions to that interface.
Lekan, yeah. There is one question in the line. Do you have a recommended vector database?
Ooh, so because we're in Germany, I give you an example. So we're using vector database because I work at HRS Group, which is in corporate travel. we're using embeddings and a vector database for matching hotel names. And this is one of our internal use cases, right? We first tried with PG Vector, which is an extension on Postgres. And we realized that the performance was okay, but the recall wasn't as much. That means the match that we're getting was not as good. So we decided to try out Quadrant, which is QDRANT. It's a German company. It's a startup in Berlin. And the performance was, from a speed perspective, right, it was 400% faster than PG Vector extension in Postgres. And from accuracy perspective, which with regards to how well it's matched, it was able to retrieve, it was about between 7 to 8% better. So I would say Quadrant, but there are lots of them outside. But if you want to quickly test, so if you want to try out a new idea, you can use FAIS, which is Facebook AI something, something, something. It's very simple. It's in memory. You can get it up and running as quickly as possible, let's say in 15 minutes. If you then want to build for production use case, I would recommend to try out Quadrant, or let's say something vector extension in Elasticsearch, or Pinnacle. I think Pinnacle. But I would say if you're starting small, use FAIS because it's in memory. You can easily hack it together in 15 minutes. If you want to go into production, consider more stable technologies like Quadrant, OpenSearch with vector extension, or Pinnacle. Or Chroma. I think Chroma, there's another one called Chroma, which is also in memory. Yeah.
Thank you for that, Lekan.
All right. That said, there is a RAG demo I plan to show, which is for me, like to the first question asked, which is which cloud provider should we use? Here, I'm using AWS in some form, and I'm using OpenAI. So for me, it's as long as whatever gets the job done within the context of, if I'm doing this at work, I probably will not use OpenAI because it means that my company data is going to be shipped outside. We'll probably have to host it. So you have to think about it in the context of in the context of the problem you're trying to solve. So if you're building something internal, this is because I'm using OpenAI right here because it's an open source project. And that's why that's why I'm using OpenAI. The one we built at work was largely based on proprietary, I think, some SageMaker model hosted on AWS. And what this use case looks like is there is some audio info. That's why we can get as creative as possible, and the limits or the bounds to this is depending on how creative we are, and we are creatives, right? We have audio messages coming from different websites. So what I did was to scrape those websites for those audio messages with content, transcribe those messages from audio to text, and then use some glue job to convert it into word embeddings, and then save those embeddings into the FAIS vector database. And then I built an app runner, which is a Docker container, which then interacts with the FAIS database, and then someone can ask it a question, and then it gets back a response. This is very simple. The code is, I think, I would find, when sharing the slides, I would also add the link to the repository. It's all on GitHub. You can use it, you can adjust it. I used it for what I did earlier and saved my work from maybe about 5 hours to maybe 3 hours or thereabouts. Feel free to use it, reuse it, and if you don't have to use AWS, use something else, as long as it helps you to get the job done within the context of what you're doing. All right, thank you. And I like Verna Vocals from Amazon will say, go build.
Wonderful, Lekan. That was really great. We have no further questions at the moment. So I will just share a poll about the call today. I hope you can see that. And I come back to sharing, Lekan.
Mm-hmm.
So if you want to continue the conversation with us, we have a LinkedIn group that I hope you can find easily if you search for GenAI Gurus. And also you can follow the GenAI Gurus page as well as the meetup group where we publish all of these events. I will not go through all of the upcoming expert talks, but we have a long pipeline of expert talks coming, so stay tuned. And with that, thank you so much, and see you in the next one.